Number one, the motion of leaves results from electrons moving from the what to the what. So originally you have this electroscope, and then you bring the positively charged rod near this electroscope. Well, what's going to happen is that this positively charged rod is going to attract all these electrons all the way from the top, all the way from the bottom to the top. Because again, the electrons can move in a metal, which means electrons go from the leaves to the knob. But then you take the rod away. And you take the rod away, well, after the rod is taken away, all these electrons here, they want to get away from each other. Since they all want to get as far away from each other as possible, they're going to spread out to the bottom. So now the bottom is neutrally charged again. And so the leaves are gonna fall back and not repel each other. So it's C, right? It goes from the leaves to the knob. You take this rod away, it goes back from the knob down to the leaves. And so the answer choice is C. Number two. So you have electroscope well, the electroscope is already positively charged, right? It's already positively charged. As you bring a positively charged rod next to the electroscope, the separation of the electroscope leaves will what? Well, there already aren't as many electrons in this knob. There are still electrons, right? And so even though you have electrons here, it's still positively charged. You still might have electrons here, but you just have less electrons than protons. But if you bring this positively charged rod up here, what's going to happen is that all these electrons on the bottom, they're going to want to move up, right? And now you have even less electrons on the bottom. So now once you bring the positively charged rod near it, you're going to have like 4 electrons here and just no more electrons on the bottom. What's going to happen? The leaves are going to separate even more now. So the answer choice is B, because you already bring this, you're bringing even more electrons. You're removing even more electrons from the bottom, is what I'm trying to say. Number 3, a glass rod becomes positively charged when it is rubbed with silk. The net positive charge accumulates because the glass rod loses electrons, right? If the rod becomes positive, well, it has more protons than electrons, and it gave electrons away. So it lost electrons, right? It lost electrons because it became positively charged. Number 4. Which diagram shows induced charge separation when a positively charged rod is held near an electroscope? Induced charge separation means that one part is positively charged and the other part is negatively charged. So we can say that, well, this part can be positively charged. Well, in the video it was negative, so let's be consistent. So it was negatively charged. And then this part was positively charged, right? Because we brought a positive rod here, and all the electrons wanted to go up here, and left the bottom positively charged. So let's say, and you're bringing a positively charged rod, so all electrons want to move up to the top. So it is D. It could, if you're wondering why it isn't B, it's because the rod was positive, right? Well, if the rod was negative, it's going to repel all these electrons, so the electrons are going to gather near the bottom. And while the leaves will still separate, you're just going to have more electrons on the bottom. So the bottom will be negatively charged if you buy a negatively charged rod near this knob. Right? So, but in this case, you're bringing a positively charged rod to the knob, so the answer choice is D. So let's do number 5. Which diagram best represents the charge distribution on sphere B? So A is negatively charged, right? It says it has more electrons. Because it says it has an excess of electrons, right? So that means it's negative. And so B is neutral. So what's going to happen if you bring these two spheres together? The negatively charged sphere wants to push all the electrons away. And so while originally B may have been positive, negative, positive, negative, positive, negative, positive, negative, you bring A next to B, and what's going to happen is that B, again, you have all these electrons here. What's going to happen is that these electrons are going to repel the electrons in B. So all the electrons in B are like going to gather to one side. And the protons don't move. So all electrons in B will gather to one side. And so the answer choice is D. Number 6. Positively charged rod. So again, your positively charged rod, it's gonna draw all the electrons to the top, right? It's gonna draw all the electrons to the top, and your bottom is gonna be positively charged. So what looks like this? Well, choice D does. Uh, it's electrostatic force, right? If water is due to just the atomic shape of water, the there are the hydrogen atoms are negatively charged, or was it the oxygen? I'm not sure, but it's either hydrogen or the oxygen atom that's more negative. And because of that, if you bring a rod near the stream of water, if it's, well, in this case, it's probably a positively charged plastic rod, what's going to happen is that the water is going to start being attracted to the plastic rod because the water is negatively charged on some parts of the atom, right? So since the plastic rod might be positively charged, it's going to attract the water as it falls down. And don't quote me on that. It's one or the other. It's either plastic rod is negatively positively charged and the water is either positively or negatively charged. I'm not going to go ahead and Google this. I probably can and figure out the answer in like a few seconds, but I don't really care that much. But the reason is electrostatic force, and so, oh, that's not, is C. And so the answer is C, right? The electrostatic force causes the water to curve towards the plastic rod because it's attracted to the charged rod. Number 8. So again, if you bring a positively charged rod, what's going to happen is all the electrons want to move to near the rod, right? And since these spheres are connected and metals move and electrons move in metals, what's going to happen is that you're going to get a more negative charge on this left side, and you're going to get a more positive charge on this other side. So what looks most like this is going to be choice D.